In section 7.2, number 22 gives us a side angle side problem where they give us, let's see, they give us side B is 385 meters, angle C is 67 degrees, and side A is 490 meters. I always like to set this up, kind of sketch a triangle, I guess, just to confirm what it looks like, I guess, and, you know, make sure it's really a side angle side. I'm a very visual person, so that my longest side, I'm not even sure if these are going to be right because I don't know what the other side is, but I'm going to just pick this and know it's not drawn to scale. So I don't know that side. And I know angle C. So this is C. I just did side B over there, so that would be, I'm sorry, side A over there, so that would be A here. And across from 385 is going to be the B. C is 67 degrees, so I also have an unknown. Whoops, sorry, that should be a little C. All right. So I see it is definitely a side angle side now. I can see that clearly from the picture. And that tells me I'm going to go use actually I'm going to grab a picture of that. So for my little summary here, I'm going to focus in on the side angle side triangle. So I'm using the law of cosines because we can't use law of sines on this triangle. I will have too many unknowns and I won't have a ratio. So my law of cosines, and I need to do it to find the third side first. So I'm finding C, little c there. So if I don't have this little cheat sheet with me, I can think about my law of cosines. I should open that too. Okay, since I'm looking for side C, that means I'm going to use this form right here. Remember, my unknown is always at the beginning or at the end. If I'm looking for a side, it's at the beginning. If I'm looking for an angle, it's at the end. I already know angle C, so this one is going to be at the beginning. So I'm looking for this unknown, this formula. So copying that down, let's see, I have C squared is the one I don't know. That's the one I'm going to solve for. And then A is the 385. Actually, you know what I'm going to do? I'm going to copy the equation down first. So C squared equals A squared plus B squared. I like that part. That part's kind of like the Pythagorean theorem. Easy to remember. And then subtract, because we're making up for the difference of the fact that it's not a 90-degree angle. If it was a 90-degree angle, then cosine of 90 would be 0 and we'd be done. But it's not 90 degrees, so we have to add that correction factor. And the correction factor is to subtract 2 times these two sides, the A and the B, and then multiply that cosine of the angle that corresponds with the first side. So that's C. So you can notice, to remember this, whatever side is here and here is repeated here and here, and the angle matches with the side, the leading side. So that's my formula. So now I'm going to plug some stuff in. I get a 67 degrees here at the end, cosine of that. Actually, I'm going to write that in the end because I'm going to run out of space here. I'm going to first solve for C. I'm going to first solve for C and then plug it in because I want to recognize that that's C squared. So to get C, I'm going to take a positive because it's a length, so I don't need a negative. I know it's the side of a triangle, so I know it's positive. C is the square root of all this stuff. Okay, oops, I don't want to go too low. And then plugging in my numbers now, I get A is 385, and that's going to get me a meter squared. And B is 490. And again, I'll get a meter squared unit. Minus 2 times A, which is 385 meters, and B, 490 meters. And when I multiply those together, I get metered squared again. And cosine of C, which is 67 degrees. And then so my units right so far under the square root are meters squared. And then when I take the square root, I'll end up with the unit of meters. So I like to kind of do a unit check to make sure everything makes sense. And these units make sense with the answer that I want, which would be a side in meters. Okay, going to my calculator now. So as a reminder, you will be using your calculator on your test for Unit 7. Lots of calculator work in Unit 7. So definitely want to be comfortable using that and finding these answers. All right. So we have C equals square root of 385 squared plus 490 squared minus 2 times 385 times 490 times cosine, and make sure I'm in degree mode, which I am. I can tell that because my toggle button is a radians, and if I change that, the default on my calculator is degrees. So cosine is 67 degrees. Close that, and I need to close it again because that first parenthesis is to close the 67. Closing it again till it says all of that goes under that square root sign over there. And I get something undefined. Oh, looks like I forgot a multiplication sign there. There we go. So it should be 2 times 385 times 490. There we go. Okay, now I have C equals to 490. The directions don't mention where to round this. I'm going to just round it to the tenths. So that is 0.8. And remember, we did a unit analysis and we found the unit will be meters. So I have that side C now. Yay. But to solve the triangle, I need more than just that other side. I need, let's see, what do I need? I need everything to fit better on my screen. That's what I need. All right, I'm going to do a little solution box right here. I need angle A, angle B, angle C, side A, side B, side C. I was given side B, and I was given side A. Don't forget your units in the solution box. I found, oops, I just put that in the wrong spot. I'm sorry. That should be angles. So capitals correspond to angles. So C is 67 degrees. My side A should be over here. And side B should be here. Side C is the one we just found, which is 490.8. So now we know how to find those other two angles. And remember, I really want to avoid that ambiguous case of side-side angle, which means I want to avoid an obtuse angle. So I'm going to start with the smallest angle, because if I can choose between either A or B, if one of them is obtuse, then I'm going to be stuck with an ambiguous situation, and I have to deal with SSA from Law of Sines, because I'm about to do Law of Sines. And I don't want that to happen. So if I use the smallest angle, then I know it's not going to be the obtuse one. So if one of them is obtuse, it's fine. I'll deal with that in step 3. But during Law of Sines, I don't want to deal with an obtuse angle. So on step 2, Law of Sines, I'm going to use the smallest angle, because the smallest angle I know will not be obtuse. All right, so what angle is smaller here? Well, let's see. A is across a 490. B is across a 385. 385 is smaller, so angle B is smaller. So I will use law of sines to solve for angle B. Okay, let's see. So that gives me, I guess I'll make everything smaller so I can fit everything. So I have sine. Okay, so this was our step 1, was law of cosines. Our step 2 is to use law of sines. Okay, good. Then I can scroll back up. All right, and our law of sines to find B, our smallest angle. So sine B is to side B, which is the 385, is sine. Now I have to choose carefully here. In our last unit, I could choose either the A's or the C's, but since I don't have all the information about A's yet, I can't do that. I have to have all the information about whatever I put in the second ratio, so I can solve for B. So I have to use C's. So sine of C, that's the sine of 67 degrees, over side C, which is 490.8 meters. I'm putting my units again, so my answer, I can just kind of do a unit analysis and make sure that units make sense. Not completely necessary when you show your work, but I'm just kind of showing it because I'd like to make sure those units make sense. Solving for sine of B. Multiplying both sides by 385 meters, I get 385 meters times sine of 67 degrees. Gives me over 490.8 meters. I see my meters cancel out. That kind of gives me a little confirmation that my unit is right. So I did something good. And then solving for B means taking the sine inverse on both sides. Now, since I know that I picked the smallest angle, I know it's going to be an acute angle, and I know it's positive, so I don't have to worry about that sine inverse only being defined on the right side of this unit circle, because I made it an acute angle. I chose the acute angle. So that's another good reason to choose that smallest angle here. I'm going to take off the units now because I already saw that they cancel out, but I'll keep the degree in there, because I don't want to forget to have my calculator in degree mode. So that gives me, let's clear all that, sine inverse of 385 times sine of 67, make sure I'm in degree mode, which I am, divided by, oops, I need to close that parenthesis on the sine, divided by 490.8, and then I'm closing the parenthesis on the arc sine, and I get that angle B is approximately, again, directions don't specify where to round, so I'm just going to go with one decimal place, 46.2 degrees. That gives me a 46.2 degrees, and that brings me to the third step of finding that third angle with the triangle sum. So step 3 is the triangle sum theorem says all three of those angles add up to 180. So if I start with 180 and subtract off the two that I know, I should be left with that third angle. And since I am allowed to use my calculator on this, I might as well take advantage of it and do that here. 180 degrees minus 46.2 minus 67, which gives me 66.8 degrees for my third angle. Don't forget my label. And then that's my final answer.